So here we're going to continue learning about slope and y-intercept, and we're really going to figure out how to find the number for slope and y-intercept. You saw this a little bit in the videos I had you watch for homework, but really now we're going to get specifically into how to find it from a graph, how to find it from a table, how to find it from an equation. All three of those can give us the slope and the y-intercept. When I talk about slope, I'm talking about how steep a line is. The slope is the steepness of a line. And you should be familiar with this. You should understand that it's either positive, negative, or zero. There is another case that we'll talk about later that's undefined, but for right now, just concern yourself with positive, which means it's going uphill, like this line. That is an uphill slope from left to right. We're always talking about it going from left to right. That is an uphill or a positive slope. You could also imagine it going the opposite direction, going downhill from left to right. That's a negative slope. And the third case we're really going to deal with is a zero slope, or just a horizontal line. That has a slope of 0. So that's just generally talking about slope, but we actually want to find a number for slope. And the way we find that, we find the rise over the run. When I say that, I'm talking about the rise as how much it goes up or down, the drop or climb of the line, and the run is how much it goes to the right. I'm just talking about it going from left to right. So how many spaces, or really counting the numbers on the bottom, how far it goes over to the right. So I'm trying to figure out the slope from A to B on the first example. From A to B, the rise here is 1. It's going up 1 space. I'm just counting the vertical climb from A to B. It's just going up 1 space. The run is how much it climbs, really how much it goes to the right, 2 spaces. So the rise over run is 1 over 2, or 1/2. You could also call it 0.5 if you're more comfortable working with decimals. The next one's saying we're trying to find the slope from A to D. So from point A, same starting point, but now we're climbing up to point D. So we're climbing 1, 2, 3 spots. You can see that's level with point D. It went up 3 spots. Our rise was 3. And the run here is how far it goes over to the right. 1, 2, 3, 4, 5, 6 spaces to the right. And hopefully you recognize that as the exact same fraction. You simplify 3 over 6, that's 1/2 also. The slope of this line is not going to change. It doesn't matter which 2 points we choose. The slope of the line remains constant because it's a straight line. I'm going to do that last example anyway. Even though I know it's going to end up being 1/2, I just want to make sure. B to F. The climb, the rise is 1, 2, 3, 4. It went up 4 spaces. And the run is 1, 2, 3, 4, 5, 6, 7, 8. Our rise is 4 over 8, also the same fraction as 1 over 2. The slope of that line remains constant. It's a straight line, so it's going to have a slope of 1/2. Doesn't matter which 2 points you choose. As long as you choose 2 points that are easy to read from the graph, you have to basically make sure that they're on the grid lines. Each of these points is on those grid lines so we can see very clearly and count it out how much it's going up and how much it's going over. So slope is really important because it shows basically how quickly the graph is changing, how quickly it's going up or down. It's really important that you look at the scale of the graph. Like these are counting by 1s, these are not counting by 1s, these are counting by 5s. So just because a line looks steeper doesn't necessarily make it steeper. The scale is really important. It tells you how fast the graph is moving up. That is the importance of slope within the context of the problem. We're going to talk about that, especially on the later examples on this problem. Now the first one just says, how far has the bug gone after 5 seconds? So after a time of 5 seconds, the bug traveled 10 centimeters. That's really just asking us to read the graph. Number 2 is saying how far has the bug traveled after 10 seconds. So after 10 seconds, we're reading the graph up there, and over to the y-axis we see that it's gone 20 centimeters. So after 5 seconds it went 10 centimeters, after 10 seconds it went 20. What is the slope from 510, which is basically what this point is describing, to 1020, which is basically what this point is describing. So I'm going to count that out on the graph. The rise from this point to that point is 1, 2, but it's not really just 2. I'm talking about this gap. It's climbing by 10 centimeters. That's the distance it's traveling, 10 centimeters. The run, this is just counting out 1 second, is 1, 2, 3, 4, 5. The rise over run is 10 over 5. That's the same thing as just 2. You could write that as a fraction if you wanted, 2 over 1, 10 over 5. Those all work. You really want to simplify it as much as possible. All 3 of these questions are asking the exact same thing. What is the speed of the bug? What is the rate of change of the graph? And how many feet per second does the bug travel? All 3 of those are the same thing, and they're all just synonyms for the word slope. They are all asking for slopes. It's exactly what we just found in number 3. It's 2. Actually, I'm going to phrase that a little bit differently. I'm going to phrase it in terms of that last one. How many feet does a bug travel per second? It's 2 feet per second. That's talking about the speed of the bug. It's talking about the rate of change of the graph. It's talking about the slope. Those are all the same thing. When you use an equation to describe a graph, the slope is always the number in front of the x. We're going to see in a little bit that we're going to describe this with the letter m. So here we would put 2 in front of the graph. That equation describes this graph, and you can kind of see how that would make sense. If you plug 5 in here, that gives you an answer of 10. If you plug 10 in, that gives you an answer of 20. It travels 2 centimeters. Oh, I messed that up. It travels 2 centimeters, excuse me. 2 centimeters every second. Not 2 feet, that would be a crazy number. It's 2 centimeters every second, and you can see that in this equation. The number of feet, I said it again, the number of centimeters is 2 times the number of seconds. So we're going to use that equation, or you can think about it on the graph. It's asking how far will the bug have traveled after 11 seconds. But we know it's just traveling 2 centimeters every 1 second, so that's going to be 22 centimeters. And you could think about that as the x value, and you could just plug it in. Y equals, or the distance equals 2 times the number of seconds. 2 times 11. The last one's saying, how long will it take the bug to travel 400 centimeters? So now they're actually giving us the distance. They're saying 400 equals 2 times some number. This is what they're asking for. We don't know the number of seconds yet. You should be able to use logic kind of there, or you can actually solve that equation. You should have learned this last year, how to solve a one-step equation. You divide by 2, and we find that it would take 200 seconds for the bug to travel 400 centimeters. Alright, this next graph is not as constant. You can see that there's parts that are going uphill, parts that are going straight across, parts that are going down. The graph is showing your distance from home when you go for a run. So I want to describe each part of this before I get into actually finding the slope. So my distance starts out as 0, and my time starts out as 0. That's the very beginning of the run. Then I start running a little bit. So after 20 seconds, I'm 10 meters from home. Okay, that's what this point is showing. After 20 seconds, I'm 10 meters from home. this next section, my distance doesn't change. This whole time, I'm still at 10 meters from home, but time is still passing. So the time goes from 20 to 40, but my distance doesn't change. That means I'm staying exactly still. I'm not moving at that time. The distance is still 10 at both of those endpoints while the time is passing. I'm just standing directly still at 10 meters away from my home. Then I'm quickly running away. Actually, you can see it here. This slope is not as steep as this one. That's basically saying I'm running faster there. And I'm going an extra 20 seconds. I'm going an extra 30 meters. That's a 30-meter climb as 20 seconds passes. From there, I'm 40 meters away from my home, and then it drops all the way down back to 0. So I was 40 meters away, now I'm back down to 0 meters away over this next 40 seconds. It's basically saying I got back to my home. That's 0 meters away. I'm back at where I started. My distance is 0 meters from my home. Okay, so now we're going to find the slope of each of these. Remember, slope is the rise over the run. So on that first one, I'm going to erase some of this to make this a little bit cleaner. On the first one, the rise is 10, and the run is 20. So that's 10 over 20. The slope there is 1/2. The slope in section B, still rise over run, but something interesting, something kind of interesting happens here. It doesn't rise at all. When I'm looking at the distance between this and this, going up and down, there is no distance. It's going straight across. The rise is 0. It's still running 20 seconds, but that really doesn't matter. 0 divided by anything is just 0. That's what we see when we have a flat line. Anytime you have a horizontal line that's just going straight across, it has a slope of 0, because it's not really rising at all. What was your speed during section C? Remember, speed, rate of change, and slope are all the same thing. The rise is 30, like we said there. Mark that in blue. And the run is this distance. From here to there is 20. 30 over 20 would simplify to 3 over 2. Alright, the slope of section D now. I'm going to erase all of this. So from 40 down to 0. That's a negative 40. This is the first time we see a negative slope. We're dropping 40. It's going straight down from 40 down to 0. That's a negative 40. Our rise there is a negative 40. The run is this part. That's going from 60 up to 100. The run is a positive 40. The run, I want you to always keep that as a positive number. You're counting from left to right, so you're going this direction. That's always going up. That's going from 60 up to 100. That's a run of 40. And now I'm going to divide this. That would give me a slope of negative 1. I want you to answer questions 5 and 6 on your own. 5 is talking about section D. Describe what that negative slope really means. And 6 is saying the slope of section C is greater than the slope of section A. Describe what that actually means in terms of your run. After you describe that, I want you to solve these 4 on your own. Actually, I'm going to do the first one with you. We're just trying to find the slope between these 2 points. So we're going to plot them, we're going to draw a line, and then we're going to find the slope. All we're talking about is the slope between those 2 points. So negative 2, up 1, 2, 3, 4. That's that point. And 1, -3 is our second bit. Kind of close. So that is our line. And now I'm going to count out my rise and run. Remember, it's always rise over run. Going down 1, 2, 3, 4, 5, 6, 7. My rise is -7. I'm going downhill. That's really important. Even if you don't know that as a -7, you can see that this is going downhill from left to right. You're always thinking about it going from left to right. It's going down 7. The run is 1, 2, 3. So my m, my slope, is -7 over 3. I can't simplify that, so we'll just leave that as a slope.